Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find all of our Twitters, the blogs, and all of the back episodes, back all the way to episode number 1 on the website there. You also be sure to stop by iTunes, leave us a comment, subscribe. There's an RSS feed on the site. You can find everything you need on there. If there's a contact form, if you have recommendations or anything you'd like to get a hold of us about. I also have, again, Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey, Brock. Hey, funny thing, it still feels like it's 2013. Why is that? Feels like it's early October 2013. Why does it feel like that this morning? Do you know?
It's because we are repeating a recording of a show, and we're going to have to thank our guests very much for taking more time out for this. I screwed up, and their audio got recorded, all distorted terribly, so we're having to do everything over again.
We need to clarify this. You were attacked by a stampede of wild boars, and they destroyed your laptop and the recording. That's what happened. That's our story.
Well, someone needs to destroy my laptop. If it's bulls, I don't care, but the truth is I screwed up, so we can move on from there. So why don't you go ahead and introduce our guests?
Gentlemen, thank you for joining us. We appreciate it, especially since we're doing this a second time. First time in RCE podcast history that we've had to re-record an episode, so we appreciate it. So, gentlemen, I wonder if you could introduce yourselves so people can hear what your voices are.
Hi, I'm Sven Breuner. I'm leading the Fraunhofer Parallel File System development team.
And hi, I'm Mohrbacher. I'm one of the developers of the Fraunhofer team, so we work together on that parallel file system. Yeah, that's
cool.
it.
All right, and so this morning, as you can tell by what they just said, we're going to be talking about the Fraunhofer Parallel File System. So I wonder... we've made this joke many times before. Brock and I are ugly Americans, and we pronounce things terribly. How was I even close by saying Fraunhofer?
Yes, pretty much. Very good.
Close enough. Okay, so I wonder if you could give us what's the 2-minute overview. What is the Fraunhofer file system?
So the Fraunhofer file system is a parallel file system, first of all. So the basic idea is, of course, that you can not only aggregate capacity of multiple servers, but also performance of multiple servers, of course. And it's a network file system in that sense. So you mount it anywhere on your compute nodes, for instance, and simply get access to pretty fast storage, depending on the underlying hardware, of course.
So looking online, it looks like there's a Fraunhofer GFS. How is that related to what we're talking about here?
Yeah, that's a common misunderstanding because we call it FHGFS. People think that the G is something separate, but in fact, FHG is the abbreviation of Fraunhofer Gesellschaft, so Fraunhofer Society in English. So FHG is just Fraunhofer. And then it's just an FS appended.
Okay, so if I see FHGFS or Fraunhofer GFS and FraunhoferFS, they're all talking about the same piece of software.
Yes, indeed. Okay,
so there's a lot of probably at least in the States better known parallel file systems out there. Luster, PVFS, GPFS, PanFS. How does Fraunhofer GFS distinguish itself from these existing offerings?
Yeah, you're right. Of course, there were other file systems when we started back in the days, back in 2005 actually. But we think they were all lacking, let's say, a combination of things that were important for us. So one is we're an HPC department, so we have a really clear focus on high performance. So the most important thing for us is that you can just get your job done as quickly as possible, right? The file system is just a tool and it should just allow you to get your job done. The other thing is that we really want to have the file system flexible. So, of course, if you can't use the file system in your environment, then it's useless to you, right? And the third thing that's really important for us is that the file system should be really easy to use. So it shouldn't be a pain to use the file system, right? It's just a tool. You want to get your job done. And the file system should just install and run in the background and do its job.
Now, you mentioned high performance there. Is that a distinguishing feature from these other ones? Or, forgive me, I am actually kind of an idiot when it comes to file systems, and I don't know a whole lot about them. Are the others performance challenged, or are you defining performance differently?
Yes, I think so. I mean, I would like to avoid comparing directly to specific other parallel file systems, because I wouldn't want other parallel file system developers, right, to compare directly to FHGFS, because they are no FHGFS experts, and I'm not an expert for any other parallel file system. But from the publicly available information, you see that they are not really that focused on high performance like we are. Right? They all have long feature lists. Some features might work well, some not so, and some have a high impact on performance, of course. So for us, performance is always a really, really important thing. And people like that about FHGFS.
So some of the parallel file systems out there, they either run in user space and use Fuse for a client, or they require kernel patches, or at least some sort of heavily modified kernel. What does it require to get Fraunhofer up and running on a system?
So basically, you talked about things like Fuse modules and client and kernel patches and all that stuff. So we do not have any of these. To be honest, in fact, in the beginning we started with a Fuse module, but we saw that this has major performance impacts. So we went to just a strict kernel module. It registers itself in the kernel, but you do not need any patches for that. So it's completely patchless. You just have to compile it against your running kernel. We support, I think, every kernel to 6.16 up to the latest vanilla. So you're not restricted to using anything special. You can just use the kernel of your choice, the version of your choice. The server side itself is completely user space. So you're pretty flexible there. You do not need to patch your kernel to get the server side running. You don't need to stick to any specific kernel. You do not even need to have a specific Linux flavor or something like that. So basically we have packages for Red Hat, SUSE, Debian, and all of the derivatives. But we can also run on any other Linux distribution like Slackware, Gentoo, or whatever you can imagine.
So you mentioned that you're a computer science shop. Does that mean that this is a research project, or are you aiming this at production clusters? What is the goal with this file system?
So the goal is to get this to production customers. We sell support for that. We have it out in the market. It is production ready since 2008. So we have it in production since 2008. The first publicly available version was 2009. In the beginning, it was just for us to have it because we had the need for a parallel file system for some of our applications, and we had a look at all the parallel file systems out there. And those that we had a look at, they just did not satisfy us because they did not deliver the performance we need, and they were complicated, and you had to do all kinds of stuff to get it working. And that was just not what we wanted to have. We wanted to have a parallel file system that just delivers the performance we need and just is flexible and easy to use. No fumbling around with kernels and all of that. Just have it in place, have it running, and it just does what it's supposed to. And then back in 2009, we just decided, okay, it's a product now, we can get it to the market and let other people use it.
So it sounded like you covered the history there a little bit. Can you elaborate maybe on what your application use case was, or also you said that it was production ready in 2008, but the first publicly available version was 2009. What kind of drove those sorts of decisions?
Yeah, sure. So first of all, the applications we had in mind. So I was not actively involved in those applications, but they were mostly applications in the sector of oil and gas, because we have a lot of customers from the oil and gas industry, and they are doing seismic imaging. And seismic imaging is something that needs a lot of compute power, and you can get it done faster when you use clusters and parallel file systems on that. So that was the point where we decided to get some parallel file system into play. And the decision to make it publicly available was just, I said it was production ready in 2008, but that's when we started to use it in production. So development actively started in 2005. Then we had 3 years to get it to that point where we started to use it in production. And when we saw that it performs well for us, then we just gave it to the public. I mean, there's some process you need to have internally to see that things are really working. You need to test, and then when you trust your product, then you can get it publicly available.
Now, you mentioned seismic processing on clusters and whatnot. Are these parallel jobs or serial jobs or both?
A bit of both. So most of the jobs, they come to us with just real slow applications and slow algorithms. And some people in our department, they are parallelizing these applications and make parallel applications out of the slow ones. So basically everything that is used in-house is parallel.
So it's probably pretty obvious where I'm going with this, given my obvious bias and background. I'm assuming these are MPI-based jobs?
Some of them, but most of them are GPI-based jobs. GPI is, let's say something we are developing to get a replacement for MPI. But I do not want to get too deep into that, because I'm not an expert in that, and I think Sven is neither. So we should
Fair
talk
enough.
to that.
Sure. Let me ask then, so MPI has this concept of parallel file access, where there's actually coordinated file access to the file system. Do these applications do that in either MPI or GPI or however they do that?
Well, I think one of the reasons why you would want to coordinate your output is if you think that your file system cannot handle arbitrary output patterns, right? So that's one thing that we, of course, always had in mind for FHDFS. It's designed for parallel jobs, right? All kinds of dirty access patterns. And of course, that's an essential part of the architecture, that there's no nothing special that you should have to do as an application developer to get your job running good on FHGFS. So it's actually not required to switch to MPI IO, right? Just do your shared file IO in arbitrary sizes, and FHGFS will handle it well.
So in terms of moving data from clients to servers, what kind of network transports does FHDFS support? Some of the more popular HPC parallel file systems support the higher performance native networks used for the MPI communication. Does FHDFS support those?
Well, basically there are two types of networks that FHGFS support. One is, of course, anything TCP IP based, right? So you can basically run it on every network with that. But of course, as we're focusing on high performance, we're also supporting the native InfiniBand protocol. And of course, the servers can speak both protocols at the same time. So there's nothing wrong with having some clients that connect over native InfiniBand and other clients that just use TCP.
Okay, so continuing down that same line of thought, you said you want it to be easy. Does that mean we can use just regular POSIX open close, so I can take maybe a vendor application that assumes a local file system and it would be able to access FHDFS?
Yes, that's exactly the idea. You don't have a specific FHGFS interface that you need to use. You just mount the file system like you do with other network file systems and just run your normal jobs on it without any modifications.
Does it support any other type of access for maybe performance reasons or just flexibility? Like, say, could I also use it as an object store? Or can I run it in like a relaxed POSIX mode to try to, relax some requirements, but, get higher performance or something like that?
At the moment, we didn't really see a need for that. So to have a specific, let's say, object interface, because we think, the workloads that you would do over a special object interface, if you do these workloads through the normal POSIX interface, then they would also be fine, right? So let's compare to Hadoop, for instance. What you tell people there is, just do your I/O in large sizes, right? To let the underlying file system handle it well, right? And if you do the same through the POSIX interface, then the POSIX interface is also quite fast again. So POSIX isn't really a limit in that sense, but it really makes sense to relax POSIX in some cases or add extensions to it, and that's actually something that we're evaluating now in exascale projects. So there's the project called DEEPR. It's a European exascale project which uses FHDFS as the underlying file system, and there we're indeed planning to add, let's say, minor extensions for open file functions and such things that can relax POSIX and help the file system to make good decisions.
Now, do you support the asynchronous IO interface as well? The idea that you can open, come back later and see, did it finish opening, do a write, come back later and see that it finished writing and things like that?
Yes, we do. So that's no problem.
Okay, let me jump back to an earlier topic. You mentioned that you were, giving away the file system. Does that mean that this is open source?
Part of it is. So at the moment, the client module is open source. As it is a client module, it makes things easier to have it open source, and you have to compile it against the kernel, so you need the source code. And on the user space side, we are in the progress of getting open source. So we would like to have the servers open source, and we're just preparing everything to get the clients to the servers open source. But that's a pretty complicated process, especially for our administration, because we started closed source and now have to get it all open and need to have the contracts and all of that finished. But of course, for people who are interested in the source code, there's always the possibility to have some NDA or something like that to get access to the source code and have a look inside.
So then what license are you distributing under? Is it your own, or is it like a commonly known commercial license?
Yeah, well, the client module is GPL, so that we can get it into the kernel. The server side is a proprietary license. It's free of charge, so you do not have to pay for the software itself. You can just download it for free. But we sell commercial support to customers that are interested in it.
So a quick question to kind of go in there with it, since it is closed source for the server. Do you support anything besides Linux?
No, nothing so far. So there are thoughts about supporting other operating systems like Solaris, BSD, or something like that, but we do not really see the need at the moment. So that's something, if we see the need for it and people are interested in it and we can find partners doing something like that, we'd be interested, but at the moment it's just nothing we see that people really need to have. So just Linux at the moment.
Okay, going off in a different direction, does the file system provide any sort of resilience? right? Some type of being able to continue in the process of localized or distributed failures.
Yes, it kind of does. So, in fact, first we just started right with a file system that should just be fast, and we didn't focus so much on resiliency. So that's something that we're now adding afterwards, let's say. So there are two options to make FHGFS more resilient. One is the well-known approach of having external shared storage between server pairs, right? Put your data on that external shared storage, and when a machine crashes or whatever, you can just do a cold failover by restarting the failed server daemon on the other machine and get again access to your files on that external shared storage. But we think that's a quite complex approach because you need third-party tools that have to do server monitoring, and if the timeouts aren't right, then you might then the system might think that the server is dead even though it isn't, and such things. So what we actually prefer is more built-in resilience, and that's why we have recently added mirroring support to the file system. So now you're free to decide on a per directory basis if you want to have the data mirrored or not, right? So you don't have to mirror all the data if you don't want to. The problem with that is at the moment that it's not high availability based on this mirroring, but if a storage target, let's say, completely fails, then you have to do a manual restore from the mirror to get your data back. So that's not ideal, of course, yet. It's kind of your life insurance for the data, right? But of course, we're still working on that to make it a real high availability system based on this mirroring feature.
So the mirroring, is that more like geo-replication type focus right now? Like what's the real focus of that?
No, it's not so much intended for geo-replication. It's really just to get to the point where one of your servers in your storage cluster can fail and you still have access to the data. So there's no notion in FHGFS of a remote server, right?
Okay, so what about block level redundancy? Some distributed file systems, you could put Ceph and HDFS in this camp. They don't rely on any underlying, say, hardware RAID or software RAID. They automatically kind of either do Arisha or replicate the data across multiple spindles, but it's in their file system. Others, on the other hand, let the hardware worry about, spindle failure, individual spindle failure. What's the approach you guys take?
Yeah, so most of the FHGFS servers typically have an underlying RAID 5 or RAID 6, right? So the system doesn't have to worry about a failed spindle because it's attached to your hardware RAID controller and will be handled transparently for FHGFS. But the mirroring, of course, is exactly what you mentioned for Ceph and others. So the file system internally handles the replication and manages it. So when we have it complete, then you might indeed want to say, well, I don't even need my underlying RAID 6 anymore, right? I can use a RAID 0 without any extra parity, and then I rely on FHGFS to keep the data redundant and protected.
Okay, that's interesting. So you're looking at, so right now, RAID 5, RAID 6, something like that, but then you're moving on to possibly FHDFS having more of the intelligence of dealing with, spindle failure and things like that, so you don't have to worry about what your underlying hardware is as much.
Yes, exactly. And in the case of FHGFS, to get good performance, the special thing here is that there are no, let's say, primary and mirror pairs, right? So it's not like every single file that is stored on a certain server has its copy on a certain other server, right? It's let's say a per file individual distribution. So let's say you have 3 servers, right? The first file's primary copy is on server 1 and its mirror copy is on server 2, but your second file may have its mirror copy on server 3, right? So it's an individual choice of mirrors for all the individual files, and that's why you always have the aggregate performance of all the machines.
So lastly, because the server runs in user space, I assume the actual file system on the spindle is not actually your own? You run on top of like ext3, XFS, something like that?
Exactly, you got it. We run on top of a local file system. It's not restricted to ext or XFS or whatever. You're free to choose any local Linux file system you can imagine, and we just interact with that file system. So you can use ext, XFS, or something like CFS, BeeGFS, or whatever your favorite choice is. Sometimes it just depends a bit on the hardware you have, a bit on the workload, so you can have some performance impact the choice of your local file system.
Now, since we were talking about spindles and failures a few moments ago, do you have any experience with SSDs, both in terms of speed and reliability?
Yes, indeed. So what we're doing in-house, let's say, and I think some of our customers would like to do the same with their systems, we have a bunch of compute nodes that have internal SSDs. And of course, you would want to exploit the special capabilities of these SSDs for some, let's say, temporary job data or so. So how we're using this is we fire up an FHGFS with each compute job on this cluster. So when you start your job on the first 10 nodes of this cluster, then we on the fly create a parallel file system on these first 10 nodes, right? So each machine is server and client at the same time. And then it's a wonderful way to store temporary data for the job there. So let's say you have a big database, right, where you need fast random access to, then you just copy it there from the normal spindles and can do your nasty small random read access pattern very fast on such a system.
So what does a typical server look like hardware-wise? You also just mentioned the interesting concept there of servers being the same thing as clients. And I think our listeners probably have their own opinions about what a client should look like, and everybody's got their own different opinions about that. But what for a dedicated server, what kind of hardware do you typically look at for that?
So basically, this is one more point where you are absolutely free to choose whatever you like to use. You do not need any special requirements. Of course, most of the customers, they are having things that you would call a typical storage server they are using. So some of our customers, they are using just server machines with external storage. These are the big customers, but we also have smaller customers who do not want to afford, and they cannot afford the shared storage and the external storage things. So they're just going with server machines that have, let's say, 12 internal disks each, and then just buy 8 of those servers and just run the storage servers on those machines. So this can be a pretty inexpensive method of getting a lot of storage if you put 2 or 3 terabyte disks in there.
So on some parallel file systems, metadata goes to one type of server, and block data actually goes to a different type of data. So you just mentioned just 12 spindles. Do you guys do distributed metadata? Like, are all servers equal? Like, how do you handle that kind of problem?
We distribute metadata, but the metadata server is a completely different process from the storage server. But when I say it's a completely different process, I really just mean it's a different process. So it's a different kind of software, but you can run it on the same machine. So we do not need dedicated hardware for that. And the metadata itself is distributed across every server that is in the system registered as metadata server. And as well as the storage data is just distributed across all of the storage servers. But you can have those services on the same machines. If that makes sense for you, I think that's a decision you have to do it for yourself and for your workload that you have. Because of course it has some impact on performance if you have it on the same machine, but in the typical workloads, most of the times you will just not recognize that.
Okay, so most users are probably putting metadata targets in the same servers as data targets?
Exactly, a lot of users are doing that. So not specifically the same targets, but the same servers. But a lot of customers have just spinning disks as storage targets and SSDs as metadata targets, but they have it in the same servers.
Okay, so I take that means that you need 2 separate LUNs minimum to kind of stand up a Fraunhofer file system. You need one for metadata and one for storage, and now you can kind of test how it feels?
No, you do not have to have 2 different LUNs. You can, but you do not have to. You can have it on the same partition if you like, because we do not sit on top of a dedicated hard drive or dedicated partition. We just need some part of the local file system that we can store the data in. So you can use the same file system for storage and metadata if you like. So.
Okay, so if I wanted to, so I'm a sysadmin and I want to kind of test this file system out, get a, not necessarily for performance, just get a feel for how it installs, how it, kind of sits on top of hardware. What's the minimum I really need to kind of do it right?
I think the minimum you really need is just a bunch of Linux systems and some free disk space. We have people just trying it on a bunch of laptops. They just take in 2 or 4 laptops and just install it and get a feeling for it. So that's all you need.
Now, what kind of other tools come with your file system? So we talked about, there's the kernel module on the client side, and a user space has some other tools with it. What are those tools, and what are they for?
Well, in the sense of making the whole thing still easy to use, the file system comes with a graphical interface out of the box. So this graphical interface can manage the entire installation of the parallel file system for you. So what you would do if you want to just try it out right in a few minutes, you download the graphical interface, and there you just enter the host names of the machines that you want to become metadata servers and storage servers and clients. And then the tool automatically logs in on all these machines, detects which distribution you're running, downloads the appropriate packages for you, and then you're basically done. So that's how easy you can set up the whole file system. And of course, the graphical interface can also show you some live statistics or send you an email when a machine is down and such things. And of course, the other thing that we have for FHGFS is a command line interface, because some people just don't like GUIs, and that's fine, of course. And basically, the command line interface can also show you the same kind of live statistics if you want, and you can do configurations like how much storage targets do I want to use per file, right? What's the chunk size per file that the file system should use to distribute the data, or it's the way how you enable mirroring and such things.
Okay, so we're talking about parallel file system for large compute problems. What's the largest FHGFS installation? Let's use 2 different metrics here, by client count and by total file system size.
Okay, by total file system size, it's about a bit more than a petabyte at a German research institute. It's called Heidelberger Institute for Theoretical Studies. So they're doing all kinds of biology, astrology, and such things. running on top of FHGFS. But that system is really just more built for size, not so much for performance. So we have quite a lot of disks per server attached. And the largest system by client count is the University of Vienna. They have about, I think, 1,300 clients in their cluster with about 12 storage servers. And we're very happy that they are just about to buy a new cluster at about the same size, and they are again going with FHGFS for the new cluster.
So who else is using FHGFS? What are some other notable names that people might have heard of or applications?
It's the research center in Jülich. I'm not sure if you have heard of it. It's very well known in Europe because it's a very large research center and a really important one. So most of our customers are actually research centers and universities and such things because, of course, they have the typical scientific clusters, right, where you need a parallel file system. And the other thing, like Christian already mentioned, are many important partners from the oil and gas industry that have the big data sets that they need to analyze from the ground data. And they, of course, also need a parallel file system to handle these kind of jobs efficiently. But we think there are, of course, many more useful applications for such a file system. Let's say the media industry, right, where you want to do video streaming and editing with high resolution movies and such things. So we would, of course, like to find a way to get in touch with these people because we think they could really benefit from something like FHGFS.
So what's one of the strangest or most unexpected uses of FHDFS you've ever heard of or ran into?
Yeah, that's a really, really unexpected one that we have there recently. It's an FHGFS running on top of NFS. So the use case here was a kind of cloud environment where you want to virtualize, let's say, everything, including the storage. And so it happened that the storage in this case was a NetApp filer that exported its volumes via NFS. And we wanted to aggregate the performance of multiple of these NFS-based NetApp filers through FHGFS. So we used FHGFS to combine multiple NetApp filers. And indeed, it worked pretty well. So we saw the aggregate performance on the client side just as.
So a question I like to ask a lot of software developers, and it's just pure curiosity on my part, is for developing the software itself, what version control system do you use and why?
We're using Git. We have switched there from SVN, and it solved some of the problems that we had with SVN, but it still leaves room for improvements, I think. But of course, it's pretty hard for the underlying version control system to make good decisions always, right? So it's just a tough problem. So I think we won't switch from Git to anything else. But sometimes it just happens that you think, oh my God, why is Git doing that? And why isn't this a default parameter? Because I always want to use it that way and such things.
Okay, so what's coming for the future of FHGFS? You mentioned the mirroring, there's more you want to do there, but what else are you thinking about doing?
Well, of course, one of the big points is the mirroring that Sven already mentioned. But another big thing we're working at the moment is to integrate HSM functionality into FHDFS. I think that's something people are really interested in because just in the academic world, you have a lot of results, and you need to keep them for future reference, and you need to keep them for years. But you do not want to have petabytes of fast storage. So it makes sense to just put those data on tapes and get them out if you really ever need them again.
I'm sorry, forgive me. You said HSM, that is hierarchical storage?
Exactly.
Okay.
So what we are trying to achieve with that is just having hierarchical storage inside the file system where people can just write their data fully transparently to our file system, and according to different policies, the data is just migrated away from the front-end storage to slower storage in the back. To achieve this goal, we are working together with another German company, which is Crowdata. They have a pretty good HSM solution, or let's say at the moment it's more or less an archiving solution, but teamed up together with our file system, we hope to get a really cool HSM solution running, which can give a really fast HSM, let's say high performance HSM.
Okay, so guys, thank you very much for your time. Where can people find more information about FHGFS, and is that the same place where if they wanted to, possibly look at a commercial support contract, please include that information also?
Yeah, just surf to FHDFS.com, and there's the big download button if you want to give it a try. And there's, of course, also the support link that explains directly how you can acquire professional support if you need it for your system.
Okay, guys. Well, that's everything we had. Thank you very much for your time.
You're welcome.
Appreciate your time, especially twice.
Yes.
Maybe the last
Thanks, guys.
time.
Yeah, hopefully so.